and even agriculture. I've seen a statistic that 200 megabits of data are generated from a so-called connected cow. Now, connected devices, a little bit more familiar to all of us, may include meters, switches, power electronics, line sensors, and the like. So we're here to draw some clear boundaries around the Internet of Things as it applies to grid edge opportunities, with the goal of describing some evolutions in Internet of Things technology and business processes. So I'm very pleased to have 4 expert panelists with me today. On my far left, we have Jeff Sharples, Director of IoT Strategy for Energy and Industrial at Intel. Next to him, we have John Radgowski, VP of Product Management at Landis & Gyr. To his right, we have Antoine Paquin, and I Americanized that, President and CEO at Cilantro. And directly to my left, we have Stuart Laval, Technology Development Manager at Duke Energy. So we have a lot to talk about and a limited amount of time here. I'd like to get right into some of the questions. So to kick things off, Stuart, what are some of the emerging use cases for the Internet of Things? In other words, why are we talking about the Internet of Things in the context of grid modernization?
So for the Internet of Things, some of the use cases that are being considered are related to the integration of distributed energy resources with the existing transmission distribution infrastructure, as well as within a microgrid. A lot of these technologies are leveraging industrial internet-based IoT protocols, which do have the potential capabilities to improve some of the communication speeds, the response times, to enable better visibility and situational awareness of data from some of our grid edge devices on the network, as well as offer enhanced end-to-end security by using and leveraging distributed intelligence.
Yeah, and John, is there anything you'd like to add about kind of the drivers behind Internet of Things development?
Yeah, I guess I would reiterate the importance of that distributed intelligence, right? So pushing out control closer to where the abnormality, right, the effect of PV is going to take place, I think is absolutely important. I guess thinking a bit outside of just renewables and kind of where things could head, right? I guess maybe a little bit further down the road is the data that can be used from an Internet of Things, right? More crowdsourced data. If you look kind of outside the utility industry, companies such as OpenSignal, right, where they use communications information from smartphones to map the cellular networks. Can utilities use crowdsourced data from the internet devices down the road to optimize the grid, right? Such as electric vehicle crowdsourced data, those sorts of things. I think, for me, where we can take it is probably, I don't think we quite know yet, right? I think we know where things need to happen, but all we can do, I think, is going to be something we find out.
Yeah, and Antoine, John touched on a point that's central to this topic. He mentioned distributed intelligence. What are sort of the requirements of maybe the use cases mentioned, but also distributed intelligence in general, and what sort of data processing architectures are we seeing evolve here?
I come from an internet background, so we've had an Internet of Things for a long time. Those things are called routers, switches, and that connect together. What's unique in this case, when we talk about an Internet of Things, we're really talking about power producing or energy rendering services devices. So you're dealing with both the aspect of communication with the laws of very large numbers. So you cannot handle real-time criticality to the communications from a system topology. And at the same time, you're dealing with control theory, control systems. In this case, intelligent systems that need to make real-time spot decisions on behavior. But if they're let alone too free, you can cause some severe instability issues in the network. So they need some supervisory level. I think what's going to be required in this case, and Duke is on definitely the right. Sorry, Duke is on my right. On my left is Landis & Gyr. I think what Duke is doing is to be applauded. That at the end of the day, you got real-time, quasi-real-time, then you got higher levels, and all of this needs to be integrated. And what's really missing we've had in telecom and in data communications is a protocol stack with agreed upon interfaces and rules at every level of the protocol stack. Some things are meant to be handled real time locally, and other things need supervisory signals. So I think it would be very important for the industry to agree not just on protocols and standards, but also interoperability, so that you can really benefit from a multi-vendor environment. You look at the internet, how do we drive the cost down in cellular and internet? Multi-vendor environment competition. And the only way it happened was standards that the industry converged upon. But in this case, it's okay to lose a packet. You don't want to make a mistake in a real-time setting. So it's a even further complicated problem.
Yeah, and certainly standards and protocols are central to this discussion. We're going to go into those in a little bit more depth in a minute. But pushing the theme of distributed processing a little further, Jeff, there's kind of a debate regarding centralized and distributed processing. How do Internet of Things technologies, big data technologies, enable the network architectures that support these applications, and what are the limitations that you're seeing?
Yeah, so I think the debate really stems from you want to be at the edge because you feel like you want to get more real-time control. And then with the cloud, what you're saying, or centralized, you're saying, I need a lot more data in order to make a decision. So I either can make a full decision with full data, or I can just use the local data. And then there's also issues like your network reliability. And there's an argument to say, well, at the edge, you don't have to worry about the network as much. And there's obviously security overlaying all of this as well. But I think the thing to think about as we go through this process of deciding where we want the processing to be, we need to think about where is the technology going to get to in the 5 or 10 year time frame when all of this is going to be deployed. So if we look at network speeds now, and we see where that trend is going to go, network speeds are really increasing. The latency is decreasing, and so what you might think needs to be done at the edge now could in fact be centralized later on. And so I think that's one of the things that utilities and the industry in general needs to look at. The other thing is this question of when we talk about control, a lot of the control that's going on within a utility may be hour ahead, 5 minutes ahead. All of that can often be done within the constraints of bringing data back to some centralized system. And so for Intel, since we build processors, we're super happy if you want to put processing at the edge or you want to put processing centrally. And what we've done is we've actually invested in a lot of the software that is now the foundation and infrastructure for Internet of Things. So we have security software, we have software on edge devices that enables those edge devices to better run applications. And so we've really shifted from just doing the hardware to now doing a lot of the software as well.
Yeah, and so we're talking about software on edge devices, but clearly, there's some requirements for field communications in that respect. So John first, and I'd like to hear from you, Stuart, to follow. As distributed intelligence grows in importance, what sort of evolutions in field communications and applications are necessary?
Sure, and standards, right? So I think everyone kind of gets that. But for me, is how those standards are applied and what that architecture looks like is probably more important. I think we all agree that we need to have standards-based implementation. The overused analogy of Apple, right? We've all heard, hey, it's Apple, it's the App Store. I don't know how many conferences I've been to and heard that. What's interesting to me, though, is when I hear about open platforms, I really think of the Google platform, really more than the App Store, where Android has about 18,000 different devices running Android out there in the world, whereas Apple's very closed, right? Very effective, very contained. So I've heard App Store. I think maybe the requirements are a bit closer to Google Android. I think the architecture is probably somewhere in the middle. I don't know that when it comes to device and OS fragmentation, that value through applications will be able to be sustained if it's too open. I don't know if there's going to be a tolerance within utilities or within software developers to maintain and kind of get into the spaghetti mess that exists right now within that Google Android layer. I also don't think, though, that there's going to be a tolerance to keep it tightly closed, such as the Apple App Store is.
Yeah, and so Stuart, would you like to comment further on sort of the necessary evolution in field communications? You know, are you more of a Apple, Android, or BlackBerry, perhaps?
Well, I think the best way to characterize how we see the network evolving is described by Duke Energy's emerging technology vision for distributed intelligence, which fundamentally is about abstracting the physical, the network, and the logical layers of data, not only in the field but also in the enterprise. A lot of these technologies will allow potentially to have edge processing capability, virtualization, as well as open operating systems, some processing memory on these grid edge devices that need to be connected to a variety of different types of wired or wireless networks. This approach is very similar to what the telecommunications industry or machine-to-machine segments are doing with what they call software-defined networking or network function virtualization.
Mm-hmm. Great. And so, Antoine, John mentioned, standards. We all agree on those. Does that resonate for you? Are you finding kind of the necessary convergence around standards at a hardware level to enable kind of the software differentiation that may be necessary?
Yeah, but there is an issue. Standards by themselves are probably insufficient. There's the issue of what a standard covers. There's then the issue of interoperability, and having a number of industry labs to validate interoperability is probably something that we all need to focus on in a cooperative type landscape. So interoperability is extremely important, but last but not least is how you certify product. And we're a chip vendor, right? So our customers are power electronic manufacturers, OEMs. And I look at the extremely varied track record of our customers in getting to product certification, and we're not talking about products with decentralized intelligence in an IoT context here. So I'm not sure that the regulatory authorities, specifically UL and other certification labs, will know yet exactly how to certify a product that is by definition distributed and relies on all sorts of other devices interoperating, and they may switch on and off, they may be added. It's a very dynamic environment. So I think labs to look at these types of scenarios will be absolutely necessary, and you'll need to involve the regulators.
Yeah, and Jeff, are you finding that there's enough room to allow for innovative solutions to some of the operational challenges regarding Internet of Things here, with the goals of standardization and interoperability in mind?
Yeah, so I think, as hard as we try on standards, we always end up with multiple standards. And so we were just on this tour of UC San Diego and their their facility, and they showed a smart charging station, and they said, look, smart charging station, and there's, depending on what kind of car you drive, you need to use a different connector because there's two of them. And then if you drive a Tesla, you need a third connector. And so you need to bring that along with you, right? And then plug it into one of these. So, and this is a physical thing that you can look at, and you can clearly see, what the differences are. So that's sort of one piece. I think the other thing is that traditionally the utilities have been able to control everything that's on their grid. So they can sort of set standards and only those things show up. But many of these new assets are going to show up and they may not have those standards, right? So one of the things we've invested a lot of time and energy in is how do you connect different protocols, how do you connect different pieces of software? And a common way to do that in the Googles and in the Amazon is through application programming interfaces. So we have capabilities to create those, to manage those, and what that does is it means that you can have an innovative piece of software doing what it needs to do. It can then expose its data through an application programming interface. The next piece of software can pick that up and continue. Those two pieces of software can act independently, they can innovate independently, but that connection remains. And so I sort of go back to that analogy of you're driving your Tesla and you come along with your plug-in API, and I think that's going to continue to be there for some time.
Yeah, and John, Jeff touched on a point there. We've spoken before, and you've talked about sort of the 30-year asset life of some of the devices going onto the distribution grid now. What's the right approach when IT standards may be evolving every 5 years or so, and some of these assets have longer lives?
So I think that's the challenge, right? So where a utility is in their deployment of smart grid, I think is really going to affect how they go about the business case and how they go about rolling those out. I mean, I think it's important that the technology standards don't change more rapidly than utility assets depreciate. It's going to definitely cause an issue. And I think that's probably some of my apprehension going into it and saying kind of where are things headed. So I think it's going to be a utility by utility choice. I think, again, that business case, whether it's AMI and distribution automation together, or whether it's a new AMI system. So, again, I think in general we need to be careful about painting one broad brush of a business case to kind of moving forward when that asset depreciation at a utility is going to be kind of top of mind for them.
Mm-hmm. And Stuart, John mentions there, keeping an eye towards the future. Future proofing is obviously a critical piece of all of this. So when you talk about the kind of utility by utility approach that John mentioned, what's the approach that Duke's taking, and how are you kind of leading that movement towards interoperability?
So typically deployments or pilots take a long time. It's very difficult to future-proof or identify a future-proof technology that is going to be out there 5, 10, 20 years. So our vision is about being flexible and being able to adapt to whatever the latest and greatest technology is. Because I don't think we know what the next and greatest app is going to be, and what the future use cases that are going to be enabled as you start to have applications running in the field in conjunction with a more rich interoperable data set.
Mm-hmm. Great, and I also want to move towards another aspect of this whole topic, which is security. Jeff, what security challenges or opportunities is the industry facing as it moves further towards distributed intelligence, a larger number of devices on the grid?
I think it's going to face all of them. So one of the interesting things is there's all these assets out in the grid, and you want to figure out how to monitor them. And the answer is to put more assets out in the grid that you then need to manage, right? So as soon as you put intelligence out on the edge, you've now got many more attack surfaces, both physically and from a cyber perspective. And so one of the things that's really interesting for us is when we go into a customer to talk about Internet of Things, everybody agrees that security is super important. Got to have security. And then we spend about 5 minutes on security, and then they say, but what we really want to do is we want to connect this device to that device and go from there, right? And adding security later is risky. It's also a lot more expensive. So we did an implementation on an experimental wind farm, and basically 5 minutes after we turned on the security system, we saw all of these attacks coming through, right? So those attacks had been occurring all of the time, unbeknownst to the folks that had set up the original system. I think that's one thing to think about. We do have ways that we can secure brownfield or greenfield devices. So Stuart talked about a hypervisor approach. And the way that works is you take an existing piece of software that's running on a substation, you put it on a hypervisor so it can run multiple operating systems, and right next to it you put security. Right? So it can be done. The trick is if you do that aftermarket, after the fact, that's more expensive. So if you know you're going to do Internet of Things, you know you're going to get attacked, then let's have security be the first topic and figure that out right up front, and then add all the other pieces on.
Antoine, does that resonate with you? You know, approach security as sort of the first piece of this process?
Absolutely. The problem with security, my father was a professor in mathematics and cryptography, so worked many years in the field of RSA, public key systems and like. The problem with security is you're trying to make things plug and play in a uniform fashion. At the same time, you're trying to maintain security. And I can tell you there's a bunch of 14-year-olds that are probably going to have a field day out there once we start rolling out these devices. I was probably one of them, by the way. I never got jail. But it will be an issue. And at the end of the day, I think utilities will need to master technologies such as public key encryption, the ability to issue keys, certify equipment, and that the equipment cannot be made operational until a key is issued to it. I mean, there's many ways to cut that, but a lot of thought will need to be put there because security and convenience go contrary to each other typically. Mm-hmm. Fortunately, we have the technology. The technologies do exist. It's an issue of system implementation.
Now, one thing we haven't yet moved to is costs, and you know there are significant costs associated with developing standards and interoperability and ensuring that devices work together in the field. So, Stuart, I want to turn to you for a minute, and you know, obviously you're approaching vendors, and there's a significant sort of impetus on your side to see this interoperability and sort of plug and play architecture. But kind of do you see pull on the vendor side? I mean, when the coalition of the willing began, it seemed like there was a struggle to bring vendors into the fold, whereas, you know, maybe a few years down the road with the second phase, we saw more interest. So what are you seeing there?
Yeah, I think that you know, now that we have a lot more interest, I think people are understanding the value of you know, having access to data, being able to share data. You know, the industrial internet segment, you know, they define essentially it as the convergence of Moore's law and Metcalfe's law. And you know, Metcalfe's law is the piece that we've kind of ignored because we're focused on hardware and improving, you know, the semiconductors inside the digital devices. But Metcalfe's law is really, it says that as you connect more devices that are compatible, in other words, the more interoperable devices are, the more valuable your entire network is. And I think it's a square. It's some proportional. So there's a you know, a value that's just compounded incrementally and is a lot more scalable as you start to tie them together. In terms of costs, utilities will continue to invest into standards. We believe that interoperability brings value, not just to us, but we can pass those benefits to our customers. And so we are lowering costs for our customers. And so we see that we'll continue to try to drive toward these open standards that can enable interoperability.
Mm-hmm. And John, are you seeing the same thing? Are you seeing utility customers willing to kind of invest in the necessary steps towards interoperability from the vendor perspective?
Definitely, and they want to be at the table in that discussion. You know, your comment about having a lab to test. I mean, there's definitely a lot of collaboration at Duke as well around, you know, with utilities to kind of come up with the right answer. You know, in the field today, we do have one of the largest networks of its kind on IPv6 being deployed in Tokyo. Right? So if some of this isn't when it's coming, it's here. There are IPv6 networks that are being rolled out. We have them in Brazil and in the Americas as well. But what's interesting to me is some of the technology we're talking about has been around for a while. Distributed intelligent platforms. We started that in the 90s, right? Before there was an iPhone and an app store. And so I think it's taking what we've been doing and then taking kind of where we want to go with that collaboration with the utility. I think it's very important.
Yeah, and you touched on an aspect of this as well that is IP6 based networks. Can you speak to sort of where we are as an industry with respect to the deployment of IP6 standards, both in the fields, but maybe also in terms of integrating with back office system?
Sure. Well, and I think that's the challenge to get the total value, right? So we do have IPv6 networks that we are rolling out as an organization, as I mentioned, Tokyo, Brazil, and in the Americas. I think the challenge, and as we're approached by utilities, and they ask what the value of going to an IPv6 standards-based stack is when you start to bring in the device and the application side and then figure security out to get total value, because that's really where they want to get, right? There's value to to the IT infrastructure, network management part of an organization, right? That's a few individuals at a utility. But I think what they're really interested in is what is the consumer value, right? The utility business case to move. And I don't think that it's going to be totally realized until we get the application and the device side along with the network.
Great. Now, Antoine, one thing that's come up, in our conversations is an issue associated with standardizing technologies that may need to be adaptable in nature. You've mentioned arc fault detection. You mentioned distributed processing for volt-var. So, how does that play out from your perspective?
This is exactly where the a common applications lab become extremely useful because, we live in an interesting age. We're probably the generation that's seen the fastest technological evolution of any generation in the history of mankind. And a lot of that has to do with CPU, thank you, Intel, and the ability with information processing to virtualize a lot of aspects. So I'll predict to you that we don't even know what's going to be rolled out in this network in 2-3 years in terms of additional functionality, either the consumer, enterprise, it could be volt-var optimization, it could be injection of reactive power. Being replicating myself here, but we don't know what we don't know yet, and as such, the ability to have both a protocol stack approach, well understood APIs to understand that enable this innovation to continue and it will continue to accelerate will be extremely important. We don't know yet what's going to be deployed out there.
Now, I did want to save a substantial amount of time for audience questions, should we have them. So if there are those of you in the audience that would like to ask our panelists a question, feel free at this time. Right in the center here.
Thanks. This is really fascinating. I apologize if this seems like a dim-witted question. I'm well outside my comfort zone here. But I'm aware of the Department of Defense program, SPIDERS, and I wonder if that has any relevancy to the types of topics you guys are talking about in terms of standardization, interoperability, et cetera. I'm vaguely aware that they've learned a lot of lessons recently through that program and that there was going to be a planned transition of knowledge to private sector, possibly you folks. So if it has any relevancy, either with that program in particular or any other federal, momentum in terms of competitions or et cetera, how much does that interplay with the types of topics you've been talking about?
Stuart?
So I think in general, we always want to have a look into what other opportunities are out there, other technologies that can bring value and essentially innovate, our use cases. That's been the approach, is to really. The one example is the Internet of Things coming from other industries, particularly the industrial segments that have similar, critical infrastructure requirements. One of the protocols within the industrial segment came from the military. That protocol was known as Data Distribution Service. It's a decentralized protocol, very robust security, low latency, and I believe the Navy, which was essentially a ship that is a microgrid, I believe handed it off to the Object Management Group standards body to commercialize that, and I believe it's been 10 years. And we're looking at potentially leveraging some of those lessons learned and capabilities from the military, so I think it's definitely very relevant.
I think the military is an excellent place to innovate new solutions. The challenge of the military, it's probably been one of the greatest sources of innovation we've known. The challenge of the military is that cost is no object, right? The motive there is win the war at any cost. But translating some of those technologies into the civilian sector is great benefit, because then all we need to do is take things that have been proven in field and just cost reduce them and make them ready for the consumers. So that would be a great area for collaboration.
I would just say that there's a vehicle for getting that kind of input in would be through the Industrial Internet Consortium, and so that is a consortium of companies that are coming together to figure out various test beds for various industries. So figuring out, what the architecture would be for energy, what it would be for industrial. So I think that would be a place where, whoever wanted to inject that could come to that consortium, and that way it could spread pretty quickly throughout the industry.
Any other questions? On the right in the front? If you'll get a mic in 1 second here.
Mason Wilrich, whatever happened to NIST? And I thought that this is the effort that is run by the Commerce Department, and I thought there was a major effort at the interoperability standards and also an interest in cybersecurity. Is NIST out of it?
I can answer that.
And the other thing is, their aim has fallen back from standards to, well, let's just see what is voluntarily possible across the industry without any particular sense of urgency. At least that's my impression. I'd love to be corrected.
Stuart, you want to start?
Yeah, so, some of the standards activities that are going on, NIST actually plays a vital role. They, several years ago, had the Smart Grid Interoperability Panel, SGIP, and since then it's now a nonprofit organization, but NIST is still a valuable partner and contributes best practices for cybersecurity. They have a test lab, and they are actively working with us on defining the frameworks that can leverage open standards for interoperability.
Yeah, I guess I'll just add a short comment to be fair to anyone on a standards board. It isn't that standards don't exist today, right? We have a network where we're running over 40 different types of devices, DA devices, across our network. That can only be accomplished through standards. So it isn't that standards don't exist today. I agree there seems to be some little entrenchment from some of the standards boards, but I think we should maybe give ourselves a little pat on the back as far as standards, because we are, I think, moving things much further than they've been.
Mm-hmm. Any further audience questions? Yeah.
Can you hear me? No.
If you want, you can go ahead and ask it, and I'll do it. Oh. You can go ahead and ask, and I can repeat the question if.
All right.
All right.
My name is Edison Almeida with eCurve. So as you talk about standards, BACnet has been around for quite a long time, and at this point in time, there are gigawatts of loads that talk BACnet. So why are we reinventing the wheel instead of just using that has been implemented already to start implementing some of your programs?
So the question is, are we reinventing the wheel when this BACnet standard already exists?
So I would argue that in general, there's not a one-size-fits-all technology that can really cover the whole spectrum of every technology on our grid. So it's our goal to really embrace each open standard, each existing protocol, where it's relevant, where the use case, where it can bring value to the use case. And so with one of the standards that I'm helping chair with the SGIP and NASB, it's a framework to really decouple the protocol from the data model. And so we can use the best protocol where it makes sense, and leverage and reuse and complement existing definitions for the domain that the use case is trying to perform. And so potentially, that protocol you had mentioned, might be an adapter and maybe have a more seamless way of retrofitting and to communicate with some of these other protocols that are already on the field. We have to take advantage of what we've already deployed, and some of these assets have been there 20 or 30 years, and we need to use them for their life. And so it might make sense to retrofit as opposed to rip and replace everything with one protocol.
Any other questions in the audience? Another one that I had myself, John, Landis & Gyr has taken has focused lately on kind of managed solutions, and with keeping costs in mind, I'm sort of wondering whether we'll see more of an appetite for owned or sort of managed and hosted IoT solutions.
I think we will. I don't know that the two are correlated much as they're parallel. I think the appetite for managed solutions in general at a utility has grown over years. I know talking about anything cloud-based 8 years ago or 5 years ago was definitely a bit taboo. So I think the mindset at the utility has shifted. But I believe it'll be in parallel with the Internet of Things. I think the one thing to really keep in mind is when we talk about the Internet of Things, from a SCADA operator, they're probably thinking of the intranet of things. They're not thinking about connected devices coming on or off of their network almost arbitrarily. I think that would frighten most SCADA operations folks. But I think when you look at the consumer side, there's much more of an internet of things, looking at in the home and getting that information back to the analytics platforms or control platforms. So I think when it comes to managed services, I think it depends, right? It depends on what we mean. Is it an intranet managed service or an internet managed service? I think as you get closer to control, there's less of an appetite, and that's going to take longer to get there.
Mm-hmm. And Jeff, I was also curious to hear, you mentioned earlier that what's edge processing now could be centralized later on. And in some cases, we're talking about challenges that need to be solved in very brief timeframes, second timeframes, maybe even millisecond. Do you really see sort of a centralized solution to these problems that require short timescales?
Well, so I'll take an example that a bunch of folks have talked about already, right? So you've got a transformer that's serving, maybe a couple of hundred houses. And on those houses, there's solar, there's EVs, and automatic thermostats, right? So if you have really good analytics on your transformer, and those analytics are using things like what day of the week it is, what events might be going on, what social media may cause the transformer to see more load, such as it's a sunny day, or such as there's a soccer game on and lots of people are watching it, they got their air conditionings on, So if you can predict when that transformer might start to overload 2 hours in advance, now instead of having to react in 5 minutes where you see the voltage start to spike and then you think it's going to overload, you've got 2 hours to make a decision. Now you've got to say, okay, what decision am I going to take? Am I going to ask some of the solar to, or some of the EVs to stop charging, right? And do I have a contract with them? Can I physically do that, right? All of that decision making, in a sense, would need to be done centrally because some of the data you're getting direct and some of the data you're getting through a cloud-to-cloud integration, which isn't at the edge. So, but the time that the additional time you have because you've been able to do the analytics, right, enables you to spend more time to make the decision and make like a full data decision. So I think as folks learn the power of the Internet of Things in terms of bringing the data in and doing the analytics, I think then the model can evolve. I think one thing that we need to be very cautious of, and this was raised with SCADA, is we're not looking to replace SCADA systems right away. It's really a parallel system in terms of bringing that additional data in. Right? So SCADA systems can't really extend down. Internet of Things technologies right now wouldn't be appropriate for real-time control.
Any further questions from the audience? Yep. Oh, over on the right.
This is fascinating. It's not my area of expertise either, as other gentlemen said, but it sounds like from what you're saying that if we have the Internet of Things and with the protocol issues that you kind of were talking about, that it may force us into a market where we have to have microgrids so that you're not running into this problem of large numbers where you have so many systems you have to control to optimize them. Is that a possibility here where we're talking about the ability to control this? It means you have to have multiple microgrids running on an overall system, and it creates the demand for that as opposed to running off the large grid.
Yeah, it's an interesting concept, I think. So the things that I've seen that have occurred is utilities will deploy smart meters. And then they'll go, great, we got all this data, now we can build a load curve with all of this data. Then they'll go, boy, we can't process all of that data, so now we have to divide up our grid just to process the data, right, from those smart meters. So then what they've got to do is they've got to catch up on the big data side in terms of being able to manage the data and being able to do it for the entire grid. So I'm not sure it'll drive physical changes in the grid, but I do think that as folks get to work with the data, they'll need to figure out how exactly they're going to manage it and what they want to optimize for. So I think it's a matter of understanding what the technology can do and then figuring out what the operational capability is that you want. And I think that's why the work that Duke's doing direct with the vendors is so important, because it's a much more rapid iteration than the traditional, let me put out a set of requirements and then wait to see what technologies come back.
I'd like to add to that a little bit, and again, I agree. I don't believe that the microgrids are going to be kind of driven by the data. I think that's going to be more of a power systems decision than it is an IT decision. But I think where I feel things will head, and I think how the centralized systems may need to evolve is more of centralized optimization, right? So of distributed intelligent resources, and I do feel that pushing the intelligence down closer to those sources of disruption is important. It's important from reaction. It's also important from utilizing the network to its best. I think that the challenge is we talk about an Internet of Things, and mostly Internet devices usually have an end user on the other side. So how do we do this? How do we create a platform to write distributed intelligent apps, I think is solving it. So I don't think it's going to drive network design, distribution network design, but I do think it's going to, again, change. So distribution management systems may have to evolve, where rather than bringing information in to react, they're more managing distributed intelligent applications, which is a different user interface problem to solve. And so I think those systems need to be evolved.
Yeah, and I would just add that, as John mentioned, there are certainly many drivers behind sort of this trend towards a decentralized, maybe more microgrid-centric energy system. But microgrids have sort of come up in our course of conversation because they do provide this test bed, whether it's Coalition of the Willing, whether it's the Industrial Internet Consortium, for really testing and ensuring the viability of the technologies that we're talking about today. So with that, we're about 10 seconds over, and we have a networking break coming up. So I think we'll wrap it up there. Please join me in thanking our wonderful panelists.